Hey guys, this is your Chem2A classmate Ayush. I'm gonna be making a tutorial video for this class on the Owl Chapter 7 homework, the last problem. Just because this problem is it's pretty complicated and it comprises of multiple different topics of acids and bases. So I figured that if you can understand this, then you should be like really good with acids and bases. So I thought it would be a good review, and also because this type of problem is really pretty complicated, so it would be good to show the steps over video. So yeah, let's get started. The pH of an aqueous solution of 0.114 molar NH4Cl is blank. The solution is acidic, basic, or neutral. We're given the Kb of NH3 is this. So how we would solve this is we would first NH4Cl. We would first write out what that ionizes into. So there we have that. And then this is one of the topics the teacher was showing us in the last lecture. So NH4C, so we have to determine if this is acidic, basic, or neutral, and if this is acidic, basic, or neutral. So what we would do is Cl minus comes from HCl, right? And HCl is a strong acid, therefore Cl minus is neutral. And NH4 plus comes from NH3, which is a weak base. So then NH4 plus should be, a weak acid. And therefore we already kind of know that NH4Cl should be technically acidic because this is a weak acid and this is neutral. So overall it's acidic. So there we already kind of have the answer to that second part. It's acidic. Now we would solve the pH, solve for the pH by, okay, let's draw a line. So let's focus on NH4 plus. pH is, remember the formula that pH is the negative log of H3O plus, so pH equals negative log. So that means we need to get the H3O plus concentration. So what we would do is we would write down NH4 plus plus H2O NH3 plus H3O plus. As you can see, it splits up into H3O plus. So we need the concentration of this. So let's make an ice table. So the initial concentration of NH4 plus would be the given concentration of this, which is 0.114 molar. And then H2O is a liquid, so don't worry about that. This is 0. It starts off at 0, 0. So this becomes minus x plus x plus x. And then okay, so we have that. Now what we need is, so this is a weak acid, so we need the Ka value of this equation. But we're given the Kb value. So basically it would, our formula for finding the we need the concentration of x, right? We need the value of x. So your formula would be 0.114 minus x equals Ka. And then we get this Ka value. Let me draw a second line. So how we get this K value is we use the formula Ka times Kb equals Kw, which means that Ka equals Kw over Kb, and then we're given that Kb is this. So the Kb of the conjugate of this is what we're given, and so that's what we use in this equation. So therefore Ka equals Kw is 1e negative 14 over Kb, which is this 1.8 times 10 to the negative 5. And then I'll need a calculator for that. So let me just reinforce again, because that's something you should remember, that if we're given, if we need the Ka of this, um, and we're given the Kb of the conjugate, then we can use this formula to find the Ka. And again, notice that this solution, it starts off with an acid, and then we're going to products, so that means we need the Ka. But if we started with a base, like if NH4, instead of NH4 it was like a base, then we would actually use the Kb for the equation. We would have this be set to the Kb. But that's not for this situation. This for this situation using the Ka. I'm going to get my calculator and solve for the Ka right now. Is that right? Yep. So there we go. Equals yeah. So then we can do we can simplify that to x squared over 0.114 minus x equals so now what we do with x is we'll actually cancel x out. I mean the minus x and the bottom, we can cancel that out just because if you think about it, like 0.114 divided by the Ka value will be much greater than 100. So again, that's another equation that the professor gave us. If the molarity over the Ka is greater than 100, then we can cancel the minus x in the denominator. So therefore we only have to solve for x squared over 0.114 equals this. We solve that and we should get so okay, so from solving that, I got x is 7.96 times 10 to the negative. And then, so that's the concentration of H2O plus. So directly from that, we can take negative log of x equals the pH, because this is a concentration of H2O plus. So then we would get pH equals negative log of 7.9. So I got 5.099. So the pH, we would put that to 3 sig figs, which means it would become 5.10. And there we have it. We got our pH, and the pH is less than 7, which confirms that this solution is acidic. Always make sure to confirm that, and then we can write 5.10. All right, so I hope that helped. Thanks for watching, and good luck in your midterms.